today we're going to talk about what is a function. So we don't always use that word very often in grade 9 and grade 10, but more so now in grade 11 and 12. We're really concerned about these graphs and these equations and whether or not it's actually a function. So I guess that's where we need to begin. So a function is simply it's an equation or a graph where you have one input gives exactly one output. So that's the rule of a function. One input has to give one output, and sometimes we can easily see this, and other times we have to do a little bit of work. But that's basically what a function is. So this is our rule, I guess, for a function. It is a function if one input equals one, I should say one distinct output. Okay, so one input gives one distinct output. So we can't have duplicates. You'll see what I mean. Just let's take a look. So a function is a relationship which maps an input value to exactly one output value. The following is a mapping that shows an example of a function. So it's kind of like a table of values, but this is called mapping notation. So this is showing you if 2 is my input, I have an output of 4. If 3 is my input, I have an output of 6. If 4 is my input, I have an output of 8. And if 5 is my input, I have an output of 10. Notice each input has exactly one output. Like we don't have more than one arrow kind of going from the same number. So each input gives only one output. So this we would call this a function. If we graphed it, actually, you would see it's a linear function. It produces a line. So we can have all different types of functions. If you notice, that's the name of this course, by the way, functions. So that's what we're going to be looking at from kind of here on in. All right, so now we have a few more mappings, and we have to decide, are these functions? So let's take a look here. If we take a look at the first one, we have a 1 that goes to a 1. We have a 2 that goes to a 4. We have a 3 that goes to a 9. A 4 that goes to a 16. And a negative 2 that goes to a 4. So every single one of those inputs goes to an output. Now, even though 1 and negative 2, 2 and negative 2 go to the same output, that's okay. We're allowed for that. But each input does go to one output. So we can say that this is definitely a function. Over on the second one, we can see there's a little bit of interesting stuff going on here. So 1 goes to 2, but 3 goes to 3, and 3 also goes to 6. So that's a case where we have an input going to more than one output. The 3 goes to a 3, but the 3 also goes to a 6. It happens again in 7. 7 goes to 2, but 7 also goes to 5. When you have an input that goes to more than one output, then this is not a function. Okay? Each input can only have one output. All right, let's keep going. All I need you to say is yes or no for these. So maybe you might want to pause and then try them out. Tell me whether yes, it's a function or no, it's a function. And as you can see, we don't always use numbers. Sometimes we throw in some other things here. But pause it and give it a try and then come back. Okay, so now we're back. So I'm looking at the top left-hand corner, and I can see negative 2 goes to 4, negative 1 goes to 1, 0 goes to 0, 1 goes to 1, 2 goes to 4, but each of those inputs has exactly one output, so we would say this is definitely a function. If I look underneath, I'm going to stick with the numbers. So bottom left, I have 21 goes to 5, 22 goes to 1, 45 goes to 0. This is definitely a function. Each input has one output. Let's go over to the cars here, though. So if I'm talking about a Honda, I could be talking about a Civic or an Accord. Notice that my input of Honda has two outputs, Civic and Accord, which means this is not a function. So you might have said no. Underneath it, bottom right-hand corner, Civic goes to Honda, Accord goes to Honda, Pilot goes to Honda, but each one of those inputs has an output, which means this is a function. So it's okay if they all go to the same output. That's not a big problem. The problem is when we have an input that goes to two different outputs. That's when we have the problem. Okay, let's continue. If we were going to look at this in terms of a table of values, basically what you're looking for are duplicates in your inputs. So in this case, we're looking at our X column, and we're trying to see with that X column, are there any duplicate numbers? So there's my X column. And I can see 2 goes to 4, 3 goes to 6, 4 goes to 8, 5 goes to 10. There are no duplicates, so this is a function. If we take a look at this one, though, mapping notation, 1 goes to 2, 3 goes to 3. Oh, we already saw this one. 3 goes to 6, 3 goes to 3, 3 goes to 6. 3 goes to 2 different places. 7 goes to 2, 7 goes to 5. Also 2 different places. So not a function. Sorry about that. I used the same example twice. Okay, so here's some table of values. So what you're looking for is we're going to look into our X columns. We're going to look at those inputs, trying to find duplicates. And here I have a -1 goes to a 3, or -2 goes to a 3, -1 goes to 0, 0 goes to 1, -1, 1 goes to 0, 2 goes to 3. We're good. We're good here. This is a function. In my next one, I have 1 goes to 9, 2 goes to 8, 2 goes to 7. Up, right there. Here's a problem. Oh, and right again, 4 goes to 6 and 4 goes to 5. So that's not a function. Okay, that input of 2 goes to 2 different answers. That input of 4 goes to 2 different answers. All right, and on the last one, I have -1 goes to 5, 0 goes to 5, 1 goes to 5, 2 goes to 5, 3 goes to 5. These are all fine. It does not matter that they all go to the same number, as long as the input doesn't go to 2 different numbers. So we are good there. That is definitely a function. All right, so kind of easy to see with the table of values. Use your eyes, look at the X columns, try to look for those duplicates. And if there are none, it's a function. And if there are duplicates, then it's not a function. Okay, so from a table of values, we can graph relationships. So definitely, I'm not sure why I have a blank one there. So, oh, here we go. So let's graph this. So if I have 2, 4, so 2, 4, and 3, 6, and 4, 8, and 5, 10. And actually, if we keep going and going, we end up with this nice line. So we can see using our eyes, these are our X values here, X values. We can see that our X values only touch one output, okay? X values only touch one output. What if I graph this one? So I'll do this one in blue on the same grid, okay? So, or actually, let me just duplicate. I can do that. Let's clone this and bring it down. And then let's bring this table down. Okay, so let's plot this. So I have 1, 2, and 3, 3, and 3 comma 6 and 5 comma 4 and 7 comma 2 and 7 comma 5. So this is what we have. So if I was going to connect these dots, what I would end up with is this. Okay, and we can see right here, this vertical line, that we have 2 outputs for the same input at 3. So 3 had 2 outputs, and we can see that also from our table right here. 3 has an output of 3, and 3 has an output of 6. Same thing if we go over here to the 7, x equals 7. It has an output right here at 2, and then it has another one right here at 5. And you can see this vertical line. So this is what we'll be looking for with graphs, is if we have anywhere on the graph where we could draw a line that would cut it in more than one spot, then it cannot be a function. So we actually have a name for it. It's called the vertical line test. We actually use a vertical line to see if there's anywhere on the function that on the graph that we can see where it cuts it more than once. So I'll show you what we mean by that on the next slide here. Okay, so are these functions? Okay, that's what we're asking. We're going to use what's called the vertical line test, and we actually just use our eyes. But to make it easier, let me create an actual line. So here, let me use this line. Okay, this is my line, this green line. Okay, so think of this as your eyes, and I'm going to move this green line across my graph. And I can see, like, for example, if I have it here, it just cuts it at the one spot right there. If I move it a little further, it's still only cutting it at one spot. If I move it over, I never can find a spot on that graph where that green line cuts my graph more than once. Okay, and because of that, then, vertical line test, this is a function. Let's go over here. Let's take a look at this graph over here. And this one I think is pretty easy to see. If I put my green line right here, notice it cuts the graph here and it cuts the graph there. 2 spots on the same graph. Same thing if I go over here. It cuts it here and it cuts it here. 2 spots on the same graph. So because through our vertical line test, we can see that we can cut our graph in 2 spots with one vertical line. This is not a function. All right, let's keep looking then. Let's go down here. Oh, a circle, a lovely circle. Oh, man, it's cutting this all over the place. 2 spots right here, cuts it here, cuts it here. We can move that over, cuts it here. I mean, there's lots of places here where our vertical line test fails. So this is not a function. Okay, and lastly, let's take a look right here. And I'm looking for where it cuts it twice. I'm moving it along. I'm still only seeing once. It's only cutting it in one spot, even though this curves up and down and up and down and up and down. I cannot find a place anywhere on this graph where it cuts it more than once. And therefore, this must be a function. All right, that is called the vertical line test. Vertical line test is just done with your eyes. And you just look and you're kind of envisioning a vertical line straight up and down where you're running it across the graph from left to right, trying to find those spots to see if it will cut it at more than one point at a time. If you can find that, then it's not a function. But if it doesn't, like my first one and the last one, then it is a function. All right, a little bit of homework, not a lot. Page 12, questions 1, 2, 9, 10, and 13 on whether or not something is a function.